Good morning, my name is Crespo, and I am going to talk to you about the metabolic effects of fructose 1.6 biphosphate. Glycolysis takes place in the cell's cytosol, and it is the beginning of glucose's breakdown to obtain energy for cellular metabolism. Glycolysis consists of an energy-requiring phase followed by an energy-releasing phase. Initially, glucose is catabolized in several steps. First, glucose is phosphorylized by the enzyme hexokinase to glucose 6-phosphate. This step requires 1 ATP. Then glucose 6-phosphate is isomerized to fructose 6-phosphate by the enzyme phosphoglucose isomerase. Then it's phosphorylized by the enzyme phosphofructokinase to fructose 1,6 biphosphate. This step requires 1 ATP. Then fructose 1,6 biphosphate divides and forms two phosphate-bearing 3-carbon sugars that eventually turn into phosphoenol pyruvates. In the energy-releasing phase, the product formed in the first half of glycolysis goes through a sequence of further transformations to become pyruvate, which is the final step of glycolysis. The enzyme pyruvate kinase catalyzes the step from phosphoenol pyruvate to pyruvate. In this process, 4 ATPs are produced. However, only 2 ATPs are the net production of the anaerobic metabolism of glucose because 2 ATPs were previously used in the first phase. Fructose 1.6 biphosphate is an intracellular metabolite that results from the phosphorylation of glucose 6-phosphate by the enzyme phosphofructokinase, which is the key regulating enzyme of the glycolytic pathway. FTP intervenes in the anaerobic metabolism of glucose as a high-energy substrate and as a metabolic regulator. FTP stimulates the action of the enzyme PFK both in normal perfused and hypoperfused tissue. Therefore, it increases the cell's usage of glucose and the production of anaerobic ATP. Additionally, FTP activates the enzyme pyruvate kinase and promotes the glycolytic step from phosphoenol pyruvate to pyruvate. Exogenous FTP penetrates the cell and is incorporated right under the enzyme PFK. FTP can recover the glycolytic pathway when it has been inhibited by acidosis and stimulates the enzyme pyruvate kinase, increasing the glycolytic flow from phosphoenol pyruvate to pyruvate. While the net production of the anaerobic metabolism of 1 mole of glucose is 2 moles of ATP, 1 mole of FTP metabolized under the same conditions will produce 4 ATPs because the ATPs required to phosphorylize glucose to fructose 6-phosphate are avoided. So as a result, the amount of ATP produced by FTP is doubled. Another effect of FTP is that it inhibits the enzyme dehydrogenase 6-phosphogluconate, which limits the metabolism of glucose through the hexose monophosphate shunt. The inhibition of the enzyme dehydrogenase 6-phosphogluconate with the activating effect of FTP on the enzyme phosphofructokinase and the enzyme pyruvate kinase produce a decrease of glucose flow towards the hexose monophosphate shunt and an increased flow of glucose to glycolysis. The use of FTP to increase energy production by glycolysis has been evaluated in several experimental and clinical studies. It has been shown that FTP treatment significantly reduces mortality in myocardial infarction and hemorrhagic shock. It also inhibits mast cell degranulation, decreasing the release of histamine, which plays a critical role in inflammation and immediate hypersensitivity reactions. Therefore, FTP could decrease the manifestation of allergies, asthma, and anaphylactic shock. I experienced the beneficial effects of FTP treatment when it was administered through an IV after presenting signs of severe allergic reactions that would have led to anaphylactic shock if not treated immediately. The beneficial effects of exogenous FTP has been shown on the increased recovery rates of burned tissue injuries, probably due to the increased ATP production. I had a personal experience with my father who suffered generalized third-degree burns due to a fire accident and pulmonary lesions as a product of smoke inhalation. With the use of exogenous FTP, he recovered completely from external and internal burns without pulmonary complications. Thank you so much.